in the server. So if we need less CPU and we need less sign-up, the good thing is that we have more battery, and this is quite important on tracking people. So this is wonderful. It looks like science fiction, but does it really work? I mean, well, you can say it, but we are talking about year 2005, 2006. Well, on the paper it looked really good, but we had to test it. We had to really make tests to check if this was good enough for our purpose. So we have to design and build a prototype. We have to test the technology. We have to test the methodology. I mean, okay, you have a wonderful device, but it really works on fieldwork. So we have to make several tests on that. And this was our prototype. It was so big and so heavy that our IT department called it the brick. I can show you later if you want it. I have it here, and I can show you. Well, but it was useful because with that we can validate the technology, the accuracy, the reliability. Someone help me, please. Reliability, all together. And we can compare the data obtained from other regular or commercial devices. So you have to take into account many things when you are testing this information: H-dop, V-dop, inertia, signal intensity, a number of satellites, proximity, many things. Well, I'm not going to explain that because it's going to get very boring, but there are so many factors to take into account. But the idea that you get is, well, we get the final points, but this is not good enough. We don't need points. We need to join that points to make the tracking. But it's not good enough because if you can see, it looks like a Spider-Man walking from one roof to another. So we have to correct them and to make the really axis of the street. And later on, we have to put it on the digital map, where also is the billboard. So later on, we can make some computations on audience measurement. Okay, it worked. AGPS, it was far ahead from compared with regular GPS. It was really amazing. We were so happy. It worked. But in fact, the next device, commercial device that really uses AGPS on a public use is the iPhone. You can, if you see the advertising, they say, well, this is so accurate. This is not a normal GPS. It's an AGPS. You can hear the Steve Jobs introduction on the 3G iPhone, so the last generation. So it worked, but now how it's going to do in fieldwork? So we make a test. We have to compare. We use Madrid and Seville, two different cities, and we have to compare this information obtained from a GPS. We have to compare it with tablet-based interviews. So to get really, if it's worth it, so much effort, so much knowledge, so much money. And we made this fieldwork test. It was a panel, and we asked 5 weeks of calibration period, because we don't know if it was 2 days, we need 2 days, 3 days, 10 days carrying the GPS, 5 weeks, 1 year. We don't know how much time do we need. So with this test, we asked for 5 weeks. And one of the most important things that we discovered, it was the quality of the data. The advantage of integrating a mobile phone in the device was not only for the accuracy of the GPS. It was that with the mobile phone, we were able to track all the panelists daily on our basis. So we were able to track it permanently. We have all our interviewers, all our panelists under the microscope. We were able to track them, to analyze their movements on each day. So, for example, if someone doesn't move for 1 day or 2 days, we phone him. Why didn't you move like yesterday? And he told us, well, I broke my leg. Yeah, it's true, it happened. And in all days we have to, we analyze all these events. People research, you know perfectly that on the panel basis, the constancy and the quality of the panel means the consistency of the data, and to keep track of all the panelists, not to have gaps, or to understand where are the gaps and what they mean. So that's very important. Why didn't you charge the battery? Or why did you drain the battery? Because we find many things, important things. Maybe they carry the device so often on the belt inside the home that they exhaust, they drain the battery. Or they don't charge, or they forgot to charge the battery on the weekend. So we know perfectly what is happening day by day. That's one of the best things of this technology, is that it's not like giving a GPS to someone and forget about him, and 1 week later download information. No, it's instantly, it's constantly, and it keeps very close to your panels. So the fieldwork was also okay. This test fieldwork showed that we were able to do a large sample later, and we were quite happy. So we need to go to the final device. And the final device should be very small, and it had to make continuous tracking. We have to keep all the people during all the time, and it has to be at least 1 day. We have to analyze the movements 1 day and then charge the battery each night. And it has to be easy. It means easy to carry, easy to charge, it's easy to use, wherever. And this is the final device. It's built by Navento. We are not the builders. This is Navento's an integrator. It uses GPS technology, and you can see it's quite small. By the way, it has no buttons. If someone wants, I can explain it why later. And it was very robust. In fact, one of the devices, one panelist forgot it on the trousers and put it on the washing machine, and it kept working later. It was quite amazing. We didn't expect that. The data was quite strange. But it has also an accelerometer, well, a movement sensor, accelerometer, so it was quite fine. Well, after that, the fieldwork is okay, the technology is okay, so now we are going for real, and we have made Madrid with 3,000 panelists, with 2 weeks of collaboration. And it's been a hell. It really was a battle. It's been quite tough, much worse than what we expect on the logistics, moving devices and making so much information flowing through GPRS. So it's been really a very tough research. But because it took 12 months, we don't want any bias on seasonality, whatever, no, what I mean. We have to reuse and recycle the devices. We use around more than 600 devices that has passed on to another panelist. We had more than 26,000 phone calls, these events that, why didn't you move, why didn't you charge, or to make an appointment, or to pick up the device. So many important contacts and collaboration with our panelists. The data transfer from the device to our server are 150 times the Encyclopedia Britannica. It's quite and it's expensive, by the way. I mean, because this goes through GPRS, so our mobile operator is quite happy with us. We are one of the best customers. And if you accumulate the data, the hours that the device has been running of all this time, it takes 38 years. 38 years of data gathered on our database. And if you sum the kilometers, it's not 1 time around the world, it's not 2 times around the world, it's 25 times around the world, all the kilometers that the GPS have recorded in this research in Madrid. So, what we learn? What we learn with this research now, in fact now we are doing it in Barcelona, but these lessons learned in Madrid and these tests and these comparisons means that new technology doesn't mean easy at all. No, it's really a nightmare. I mean, it's not easy to adopt or easy to integrate. Of course, it's a quantum leap in information gathering. It's cool, it's high-tech, it's accurate, you've seen, it's wonderful. And puts the bar so high. But when you ask for new technology and research, you have to be really focused on that. You have to put time, you have to put money, you have to put resources, full-time resources on develop that. It can be, oh, why don't we do GPS? Oh, we make some tests. It's not like that. It really means a very hard work